When we have a fever, we feel hot, achy, tired, and the first reflex is usually to take medicine to bring the fever down. But is that really a good idea? In fact, a fever is one of the most ancient and intelligent defense mechanisms that life has ever developed to fight illness. So, what exactly is a fever? Why does it help strengthen the immune system? And should we try to lower it?
Temperature, the source of existence.
On Earth, life can exist within a very wide temperature range, from -10 degrees Celsius in frigid, deep-sea lakes to 120 degrees Celsius at hydrothermal vents. However, life cannot survive if it goes beyond these limits. Every organism has an optimal temperature that allows it to function most effectively, as well as a tolerance range within which it can temporarily survive.
For humans, the optimal temperature is around 37 degrees Celsius. This is the temperature level at which cells function best. Enzymes work most effectively, and the body is in perfect balance with the environment. Humans are warm-blooded, which means we expend a lot of energy to keep our body temperature stable. Although this might sound inefficient from an energy perspective, it offers an immense benefit. Our body temperature is so hot that most types of parasitic fungi cannot survive. While many cold-blooded animals are vulnerable to fungal attacks, the human body is essentially a no-go zone for them. This variability to control temperature is also the foundation for a familiar phenomenon, the fever. For bacteria and viruses, your body is a world full of resources waiting to be seized. When you have a fever, the body implements a defensive climate strategy. It raises the temperature to push the enemies out of their optimal survival range. This is an evolutionary tactic dating back at least 600 million years, appearing in countless species. Sick fish will swim to warmer waters, lizards will bask in the sun, and bee colonies will heat their hives to kill pathogens. Humans, being warm-blooded animals, have evolved this ability to the next level. We can heat our bodies from within. When infected, the immune system releases pyrogens, fever-inducing substances. They travel to the brain, signaling the control center that the body needs to raise its temperature. As a result, you start shivering. Your muscles contract continuously to generate heat. The blood vessels beneath the skin constrict to keep internal heat from escaping, making your skin feel cold while your body is burning up. A fever is a systemic response that consumes a huge amount of energy. Every time your body temperature rises by 1 degree Celsius, the body must expend an additional 10% of energy just to maintain vital functions. That is why you feel exhausted when you have a fever. It's the time the body is channeling all its resources into the immune system. Inside the body, when bacteria begin to invade, they try to hide from the radar scanners of protective cells. But as soon as they are detected by the immune system, they switch to a frenzied reproductive mode. They require a lot of energy and nutrients and become extremely aggressive. Your immune system knows this, so it deliberately makes the environment inside the body more hostile by causing inflammation, which floods the infected area with fluid, antimicrobial proteins, and a massive number of immune cells mobilized to the site of infection. The high temperature caused by the fever destroys the structure of the bacteria, damaging their cell membranes, deforming proteins, and breaking down DNA. They are literally living in a thermal hell. But fever doesn't just harm the enemy. Your own cells are affected as well. Almost every organ in the body functions less effectively when you have a fever, except for one thing: the immune system. During a fever, immune cells become highly efficient. Neutrophils move faster. Macrophages kill more bacteria. Killer T cells identify targets more accurately. The immune system also cuts the supply line to the bacteria, blocking their sources of raw materials like iron, glucose, and glutamine, all things they need to proliferate.
Viruses that have infected millions of cells suffer even more severe damage, as they are extremely sensitive to heat. For example, the rhinovirus, the culprit that causes the common cold, can only invade the respiratory tract because this area is significantly cooler than the rest of the body, even when you don't have a fever. High temperatures are also truly terrible for the millions of cells currently occupied by the virus. These cells are already working flat out to produce more viruses, a strenuous and exhausting process. When the heat becomes too much to bear, these stressed cells start to panic. As their internal machinery begins to break down and fail, they rapidly generate billions of heat shock proteins, known as HSPs, to try and repair the damage and keep themselves alive. But it's a trap. Healthy cells also produce HSPs in response to high temperatures. But if a cell generates too many HSPs, it signifies that it's under more severe stress than usual. And if that stress level crosses a limit, it's a sign that the cell has a problem and needs to be eliminated. At this point, natural killer cells and killer T cells are activated and attracted by the HSP signal, then begin to destroy the infected cells, along with all the viruses inside them. Unwittingly, in their attempt to save themselves, the infected cells send out a call that leads them to their own destruction. If fever is such a powerful weapon, why haven't our enemies been able to fully adapt over hundreds of millions of years? There is a truly astonishing answer. Fever is an evolutionarily brilliant tactic. Imagine this. If pathogens were to survive and thrive in the high temperatures of a fever, they would quickly be naturally selected for heat tolerance. After just a few days, they would become adapted to the searing environment inside your body. However, this adaptation becomes a shackle when they prepare to spread. When those heat-resistant microbes invade a new, healthy host, the normal body temperature of 37 degrees Celsius actually becomes too cold for them. The heat-tolerant invaders now have to struggle within the new host body, which is at a normal temperature. This creates an unsolvable evolutionary trap. They can only adapt to one of the two environments, hot or cold, but they cannot adapt perfectly to both. To evade this trap, dangerous pathogens like the measles virus have chosen the tactic of blitz attack, lightning strike. The measles virus replicates at hyperspeed and is most highly contagious right before the fever peaks. Although the immune system then brutally suppresses them, the goal of spreading has already been achieved. In summary, a fever isn't just a flame that burns the enemy. It's also a strategic move that helps the immune system always stay one step ahead of the invaders. If fever is so beneficial, why do we try to lower it? In truth, the common use of fever-reducing medication has only emerged in the last 100 years or so. For most of human history, fever was seen as a natural signal, indicating that the body was fighting and needed rest. Today, because pain relievers and fever reducers are often sold together, many people unintentionally lower their fever when they only intend to treat a headache. Especially with children, parents often fear high fevers and administer medication as soon as symptoms first appear. But in reality, a fever under 40 degrees Celsius is not harmful and generally does not require intervention. Of course, pregnant women, the elderly, or critically ill patients need careful monitoring, as a prolonged fever can exacerbate their existing medical conditions. Some studies show that fever-reducing drugs don't help patients recover faster from the flu or chickenpox. Furthermore, in one trial, when critically ill patients had their fevers aggressively lowered, the mortality rate increased, forcing the researchers to stop the experiment. Therefore, in many cases, allowing the body to naturally run a fever can help you recover faster and more effectively. Of course, unless there is a specific medical contraindication. Always follow your doctor's advice. You should not make medical decisions solely based on a video or an article. However, if the fever is not too high and you can bear it, allow your body to do its job. Because while you are burning up, your immune system is incinerating the invader within. If you feel too exhausted, taking pain relievers or fever reducers can help you feel more comfortable, even if the immune response might be weakened slightly.
Whatever you choose, remember that while you are struggling with the fever, the enemy inside your body is suffering 100 times more.